The video was about how to solve a quadratic equation using factoring. And so our first step is going to be to write that quadratic equation in what we call standard form, ax squared plus bx plus c equals 0. So descending order on the exponents. The next step then is to factor completely the thing that we've just been working at and working at and working at. Once you've factored completely, the rest is the new stuff. And we can talk about this a little bit too. The zero factor property is used to set each factor equal to 0. And then we solve. And did you notice in the video we got two different answers, like two different solutions that worked? And that will often, not always, but that'll often be the case in these scenarios. So let's talk a little bit about the zero factor property. And let's talk about the number 0. 0 is very special because any number times 0 is 0. It's really important that you think of this as the zero factor property. I usually use the three letters ZFP to refer to the zero factor property, just the acronym. And so it's really important we understand that it's the zero factor property, not like the 10 factor property, because you can't say that any number times 10 gives you 10, right? But you can say that any number times 0 gives you 0. Okay, so let's practice a few of these here and see how you do. We're going to start with number 2. So number 2 says solve x squared minus 100 is equal to 0. Let's take a look first here and let's identify, is that x squared minus 100 equals 0? Is that already in standard form of a quadratic, or do we need to do something to kind of get it to standard form? What do you think? Is it there or not? No, what do we need to do? Well, so I'm just talking about this first step. I agree that we're going to need to do some factoring. 100% agree with you, but that's kind of like step 2. Step 1 is it in standard form right now? I'd say it is, right? So you got descending order on the exponents, you got x squared, and then b happens to be 0, and then your c is negative 100. So it is in standard form. Now we got to factor completely. This is the next step. And we're all in different places. It's very obvious from our quiz yesterday. We are all in different places. You're going to hear some really interesting statistics from our quiz yesterday. The most common score on the quiz yesterday, you may or may not believe this, was a 100.
What?
Yes, dead serious. I'll show you the stats if you want. If you look at a little bar graph, the bar on the 100 is the tallest bar. But there were some other grades that were not as good. I'll show you the stats if you want. In fact, whether you want to or not, because some of you are looking at me like, nah, that's not true. I'll show you. So my point is this. We are all in very different places with factoring. Let's take our time and go over this. X squared minus 100 is equal to 0. Let's take a look first here. Is there a GCF that I could factor out of that x squared minus 100? Between the x squared and the 100, is there any number that goes evenly into both?
No.
Do they both have an x?
No.
They don't. And so there is no GCF to factor out. All right, so once you factored out the GCF or determined that there is no GCF to factor out, we want to look at what's left over. How many terms are there? 2 terms. And then I think this is a good question. The next question would be, is that x squared minus 100, is that the difference of 2 squares?
Yes. Wait.
For those of you, listen, for those of you that were like, I don't know, check it out. Does that symbol right there mean difference?
Yes.
It does. Subtraction is difference in math. Yep. Is that a perfect square?
Yes.
Is 100 a perfect square? So is that the difference of 2 squares? Yes, it is. So you can go about this 2 different ways. You can use the split the b method to get there. I would be highly encouraged, and I think you should be too, if we could remember that the difference of 2 squares always factors with what I call the plus minus pattern. Now check this out. You can factor this fairly quickly. If you say, all right, x squared minus 100 is the difference of 2 squares, it's going to follow the plus minus pattern. And then all we really have to do is ask ourselves, what times what is x squared?
Negative 10 and 10.
Well, you're doing the other one. I did the first one. So x and x, right?
Yeah.
And then what times what is 100?
Negative 10 and 10.
There we go. So it's x plus 10 times x minus 10. Okay, now if you have any questions about that, if you're like, whoa, that seems too easy, I don't know if that's really the right factoring or not, what could you do?
Check it.
Check it by FOIL it back out. And if you FOIL it back out, I think you would see that, yes, for sure, this is the right factoring. Oh, like x minus 10 times x plus 10, like if you flip the order. It doesn't because with multiplication, order doesn't matter, right? It's commutative. So either way should work just fine. Are we okay with the factoring part there? Did I take you through a good mental journey to get there? And you can always check, right? If there's any doubts, you can always check. So that is actually all old stuff. Here's the new stuff, the zero factor property. So the zero factor property tells us that if I have something times, not plus, not minus, not divided by, but something times something else, which is what the factoring is, right? Something times something. If I have that situation and the answer is 0, then wouldn't it have to be true that either one of the two factors or both would be 0? Like if I told you that there was some, listen please, here's the logic of the zero factor property. If I said I'm thinking of two numbers, think about this. Like what if we made a contest out of this? You should be able to win this contest every time. What if I told you guys I'm thinking of two random numbers, two completely random numbers, and if you multiply them together, the answer is 0. What's one of the numbers? Wouldn't you say 0? Wouldn't any other number be a terrible guess? I'm thinking of two numbers, and if you multiply them together, you get 0. What's one of the numbers? You'd have to say 0, wouldn't you?
1.
That's the zero factor property because anything times 0 is 0. So here's how you would proceed using that. Zero factor property would tell us to set the first factor equal to 0, and it would tell us to set the second factor equal to 0. And if you notice, the final step is to solve each resulting equation. So then, what would I need to do to solve this one right here?
Get the 10. Subtract.
Subtract 10, yeah. So my first answer would be x equals negative 10. And then what would I have to do right there to solve that one? Add 10? Does that make sense? Does it make sense? Will? Yeah? Okay, cool. So x is equal to positive 10 or x is equal to negative 10. You could actually check this. You could actually go back even further and check this in the original. You'll find that both negative 10 and positive 10 make the original equation true. Yes, ma'am?
So basically the final answer is just going to be the number with the x.
So now you're seeing a pattern that's not necessarily there because you could have 2x minus 4. There's going to be a little more to it than that. So be careful about jumping too quickly. In this specific instance, yes. But other factoring patterns, no. So don't make that leap too far. Can I give you an idea about what I would expect to see on a quiz or a test? I hope this would be of interest to you. I would want to see for sure that you factored the expression correctly. I want to see correct factoring. And I want to be really clear about this. I want to also see the zero factor property step where you set each factor equal to 0. So I want to see x plus 10 equals 0. X minus 10 equals 0. And then, of course, finally, I'd want to see the answers. Does that make sense? Okay, cool. Well, let's see what you guys can do with number 3. I'll give you a chance to work this one on your own. Here it is. You know what? Let me help you get started with this one, and then I'll turn you guys loose. Let's make sure we start in a good spot. Let's make sure we all start in the same place. 15x squared is equal to 45x. Is that right now in standard form? Why not? Yeah, they're on opposite sides, an equal sign. And with these quadratic equations to be in standard form, we basically need blah, blah, blah equals which number? 0. And right now it's not that. So what could I do with this equation to get it to be all the stuff on one side equals 0?
Subtract 45.
Yeah, get that 45x over there by subtraction. So I'm going to start off with this, what you guys said. So minus 45x minus 45x. So I'd end up with 15x squared minus 45x is equal to 0. Now, I'm going to leave the rest up to you. Step number 1 is to factor completely. Step number 2 is to set each factor equal to 0. Step number 3 is to solve the resulting equation. So we're going to start off by trying to factor this. And remember, all the factoring stuff we've been working on still applies. You always want to start off by trying to factor out a GCF, if there is one. In the previous question, there was not a GCF. This one there might be, and so you want to consider that as you move forward. So give you guys a few minutes to try this one on your own. This one would be a GCF. The leftover would be that. Did you guys get that for your factoring? Do you have any questions? Emily, you look like you might have a question. Am I right?
Yeah.
Okay. So let's go back. I got to do this sort of quick because we got to keep moving forward. There's two terms right here, right? What do they both have? Like, what's the most obvious common element? Like, what do they both have? They both have an x, right? So I'm going to just put this out to the side and say, okay, the x is definitely going to be part of my GCF. okay? But we still got the numbers to deal with, right? The 15 and the 45. And so you can list out 15 is like 3 times 5, and 45 is 3 times 3 times 5. But I would encourage you to start to try to move to a place where you'd say, all right, what's the biggest number that goes into 15 and 45? So you might say 3, right? So you'd say, all right, I think maybe it's a 3. But then if you started to think, well, wait a minute, they both end in a 5. Isn't that like a key mark of something that's divisible by 5? So a 5 goes in there too. So if a 3 goes into both and a 5 goes into both, what's really the GCF? 15. 3 and 5. Yeah, here, I'll show you again. I really want us to try to move past this, but here's what you can do. You can look at this and say that it's 3. Guys that are speaking over there, please stop. Thank you. It's just really distracting. So you can do this, right? And this is tried and true. This will work every time if you do it right. But I'd like for us to start to grind and slowly move away from this. Don't look at this. This is just way too slow for you. It is. So you'd say, hey, look, there's a 3 in common, and there's a 5 in common, and there's an x in common. So if you've got a 3 and a 5 and an x in common, the GCF would be 15x. And then what's left over on that first term? And then on the second term, the only thing left over is a 3, so the inside leftovers would be x minus 3. Does that make sense?
Is that the answer?
No. I just said, hey, is everybody doing okay with factoring? And a couple people made kind of that scrunched up face like, no. So I went ahead and looked at the factoring. Do you know why I know it's not the answer yet? Because in the end, I should have x equals this and x equals that kind of thing. So are you guys okay with the factoring, though, at this point? Okay. So that's the complete factoring. Now we're going to use what's called the zero factor property, and we are going to try to solve. And you know what, Garrett, I would say this is probably that point in time where when we misuse the word solve, we get into problems. So sometimes we think of the word solve as describing us just like doing something, like completing something. And so it's really important to understand that solving means that you have x on one side, then an equal sign, and then some number. That's what solve means. And so we need to solve this equation for x. Zero factor property tells you to do this. If you've got something times something and the answer is 0, you take the first something, and in this case the first something is 15x, and you set it equal to 0. And you take the second something and you set it equal to 0, like that. And at this point what I've done is I've set each factor equal to 0. Think about those words. Here's the first factor, 15x. Here's the second factor. And this goes back to that number game. If I told you, hey, I'm thinking of 2 numbers, and they multiply to be 0, what's one of the numbers?
2.
You would have to say 0. That would be 2 would be a really terrible guess. I got to say, Haley, I'm sorry. But 0 would be a great guess because you know that anything times 0 is 0. So if you've got something times something else, and the answer is 0, to solve the equation, you set each of the factors equal to 0. Are you with me still?
Yes.
Okay, so now to solve this, we divide both sides by 15, and we get x is equal to 0.
And x is equal to 3.
And over here, you add 3 to both sides, and you get x is equal to 3. If you were to take those two numbers, either one of them, and plug them back into the original equation, you should get a true statement. It should make the original equation true. Okay? So I know that number 2 and number 3 looked a little different on some of the in-between steps because the factoring was different. But are you seeing the common elements between the two? Okay, let's keep going. Let's take a look at number 4. Let's see if you guys can do this one. Let me help you get this one started, and then I'll turn you loose. Number 4. Okay, so please take a moment, look at this, ask yourself, is this equation as it currently stands, is this quadratic in what we refer to as standard form?
No.
Why not?
Because the 15 is bigger.
It needs to be everything on one side equals which number?
0.
It needs to be equal 0, so I need to add 15x over. And can we be super careful that as we add the 15x over, that we make sure we put this in descending order? So if I add 15x over, it's going to fit in right there, actually. So it's going to give me 2x squared plus 15x minus 8 is equal to 0. So once you get to this point, you are in standard form of the quadratic. Now the first step is to factor, right? So see if you guys can use whatever tools you have in the toolbox to factor that, and then use the zero factor property to then solve for any solutions you might get. Okay, so I'm going to again let you guys work on this, the factoring, and hopefully we got it in standard form, and you guys already decided that there's no GCF, so that's good. So my first step then would be to find my AC. I'm going to split the b here because I've got a trinomial. And my AC is negative 16. My b is 15. And I got to ask myself, which two numbers multiply to be negative 16 and add to be 15? What would you say?
Negative 16.
Yeah, I got it backwards actually. I think it's positive 16 and negative 1. So positive 16 and negative 1 work with our x. Okay? Is that good? Now this is the step that I saw people kind of missing here. You want to split your b up. So your next step would then be 2x squared plus 16x minus 1x minus 8 is equal to 0. So I'm splitting that b up according to the numbers that I got for my x. Once I've split the b, that's when I group the first two, and I group the second two, and I add the groupings. So I'm just going to sneak a plus sign in there. Once I've done this, I need to ask myself what the greatest common factor is for the first grouping. What do you guys see? What goes into both 2 and 16? 2. And there's also a common x. Agreed. So if I factor out a 2x out of the first grouping, what would be left over? X plus 8, because 16 divided by 2 is 8. Now the second grouping, it almost looks like there is no GCF. And the truth is, you might be able to leave it like that, but we want the leftovers to match. So if I didn't factor anything out of the second grouping, would the leftovers match? What do I need to factor out of it to get the leftovers to match? Negative 1. Yep. So I factor out a negative 1. The leftovers then would be what I wanted them to be, which is x plus 8. And then I just need to do a GCF one more time. If you notice, between those two terms, there is a common factor. The common factor is x plus 8. So as I factor that out, it would be x plus 8. The leftovers would be 2x and minus 1. So it would be x plus 8, parentheses 2x minus 1 is equal to 0. So that's the full factoring. And there were definitely some challenges, some struggles in there. You'll get a chance to practice that again here in just a second. We'll just do one more after this. Now, if we're supposed to solve, we haven't solved anything yet, right? Because it's supposed to be x equals this and x equals that. And so I need to use the zero factor property to set each factor equal to 0. So here is that ZFP. It would be x plus 8 is equal to 0. That's the first factor. And the second factor set equal to 0 is right here. So I would end up with x is equal to negative 8 when I subtract. You know, let me actually move that a little bit. I would get x equals negative 8. And then how would I solve the second equation? What would I do first?
Add 1
Add 1,
to the other side.
and then divide by 2.
Yeah.
So I'd end up with x equals negative 8, and x is equal to 1/2. If we checked both of those answers in the original equation, we'd see that they both make the original equation true. All right, are you guys making a good connection between the factoring we've been doing and what we're doing today? I hope you can see that it's the exact same stuff. I'm going to give you guys one last chance to try here. Number 5, take a look at it. Solve 9x squared equals 30x minus 25. Give you a chance to try kind of the full deal on your own. See how it goes. Work together to get there. You want to navigate here. I'm not going to do the whole thing right now. I just want to make sure we all start off in the same spot. I've had a number of folks ask, hey, why don't I just do, well, hang on. People have said, essentially, why don't I just subtract 9x squared over? And while you certainly can do that, there's no rules against that. I don't recommend it simply because I found it to be easier to have your a value to be a positive number instead of a negative number. So if I were you, what I would do is subtract the 30x over and add the 25 over. And Cole, this is that step where you're going to want to make sure you leave yourself enough room. Try not to take up half the thing with just this step. So that's going to give you 9x squared minus 30x plus 25 is equal to 0. So once you get it to that standard form, you should be able to identify your A, your B, your C, do your X, and split your B, and get it to a factored, okay? So keep working on it. So on this one, the X was tough, wasn't it? The X was kind of tough. Your AC is 225. Your B is negative 30. Cole, did you get this one? You were like wrestling with this. Isn't it negative 15 and negative 15? Yes. Okay, so negative 15 and negative 15 for your two numbers that work. And so then we split the B. We write 9x squared minus 15x minus 15x plus 25 is equal to 0. This is, I need to actually do a little better job here. This is where we group and add the groups, and we factor out the GCF from each group. So between 9x squared and 15x, what's the common numerical factor?
3x.
3, and then there's the x in common as well. What's left over?
3x minus 5.
You got it? Okay, and this next one is tough, right? Because you can either factor out a positive 5 or a negative 5, but you want the leftovers to match. So which one do you do? Do you factor out a positive 5 or a negative 5?
Negative 5.
Negative 5, good. And when you factor out a negative 5 from negative 15, you get 3. The x is still there. And then as I walked around, what you guys did was actually pretty common. Positive 25 divided by negative 5 is negative 5. Other than that, you guys had it exactly right. Okay, then you factor out the common factor one more time. And this one's unique because the leftovers actually match the common factor. So this is that case where you've got a perfect square trinomial and there will simply just be the one answer. Use the zero factor property to get this set up, and you would just really have to do one of them only. 3x minus 5 equals 0. Therefore, you would add 5 to both sides and then divide by 3, and you get your only answer, x equals 5/3. That was encouraging. Walking around, there was a really high percentage of you that got that. Carissa, did you find your error? Because you had the wrong sign.
Yeah, I just divided by 3 instead of maybe like the last step.
Oh, okay. So I want to look at your factoring here in a second. Okay, cool. All right. We're done for now. You guys can put your notes away.